guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. The crux of it. This is your primary relay. Right here. Okay. RF comes in, goes out through this junction point. This is the switch that says thou shalt pass or thou shalt go down this other road. Okay, so RF is either going to come directly through here or it's going to get switched, get amplified, and then come from here and go out. So this is where we're going to start our conversation on what's actually taking place. There is this bar that is right here that comes off the relay, a little tiny piece of open copper tinned wire. It's going to go through this pass-through and it pops out on the other side here. Now, let's talk about its path. RF is going to come down this wire and come over here to this particular back band switch here. Now you got to have two band switches, for the input network on this particular amp. And the reason for that is you're going to have an inductor with a piece of ferrous material, going through the inductor. And that's what these little tubes are. There's a piece of ferrous material that you can have access to this to adjust this, but you have to take the whole top section of the amplifier apart. We don't have to do that for this particular setup. Kenwood was super cool, and they went ahead and provided us with every single thing that we need in here to do this modification, short of 2 wires. So I'm going to show you how to do this so you can use it in 10 meters only. And I strongly, and I cannot suggest that enough, that really this comes down to the operator's discretion. And me personally, I'm not a big fan of doing these, but I thought I'd throw this out there anyhow so people could learn. The RF comes in and it goes across the top and the bottom of each one of these inductor coils. There's a coil, it's going to come from the top and the bottom. Okay. So RF is going to come in, go across the inductor, and there's either a capacitor at the top of the inductor or a capacitor at the bottom of the inductor. Both of those are very important, but for the ease of simplicity for us to work on, they made all of our solder connections up here on the top of each one of these things. Now, here's the tricky thing, is the coil that they've provided for us is actually in here, but they've buried it and hidden it. Okay, so the RF comes in, and when you get to the 21 megahertz frequency selection on the front of this thing, the point where the 21 megahertz hooks up is here. Now they've got capacitors that go directly across the top of this coil over to another shorting bar to here. RF is not going to go down through this choke. It will always take the path of least resistance, which is going to be directly through these capacitors. RF is AC. Okay. Why is this choke bypass? That would be our very first clue to look at. It's present, it's tight in the circuit, it's there for a reason, and it's already pre-adjusted. But now what they've done is on the other side of this, they've got another capacitor hooked up here, going directly back to ground. Then you got 2 101s coming back going to ground. But the shorting bar between these two tubes, that's the mystery link. Okay, so as you move the armature through its motions, you'll find that there's a tab that's open right here. And then when we go look down here on the inside, there's another tab that's open right here. So what we're going to do is we're going to take this wire that goes here and we're going to move it over to here. We're going to take these capacitors off. We're going to take this capacitor and put it here. 21 megahertz is going to work fine. So from there you're going to take one wire and go from here to here, and then from there to here. And that is the key. So once you get your induction right, because remember, you can take enough induction and enough capacitance and you can tune up a wood fence post. You ain't going to talk for shit, but all your equipment's going to think it's all good to go. So, with a little bit of induction and a little bit of capacitance, we can make a matched input resonant network for this thing. Okay? We're going to use this tuning slug to do it. Period. There's a couple of the little tricks that we go as we go. I'm going to show you. It's going to be really super simple. We're going to add 2 wires, and we're going to flip-flop some capacitors. And we're done. And then the 28 megahertz band, which we all have licenses to operate on and use this equipment with, will be totally open to you. So let me go ahead and do the first couple steps, which is going to be removing this shorting bar, moving this wire. I'll show this to you again. I'm not going to move the camera, so you'll have a visual reference on what you need to do. I'm going to go ahead and move this wire over here, take this shorting bar out, disconnect these capacitors, disconnect these capacitors, and disconnect this capacitor here. Okay, so what we've done is we removed the shorting bar, and these are the parts that you're going to have left over. You're not going to need these ever again. Okay? Oop, there's frame. Turn the camera around. There we go. These 2 capacitors, which is one's going to read 151J, and the other one's going to read 101J. You take these out and set them aside. You're not going to need them anymore. Okay? Now, going from the top post to the band selector here, and counting, this is the front of the amplifier, counting to the right, 1, 2, you're going to have 3 wires, but from the top of the band selector, you're going to have post 1 and post 2. You're going to take post 2, and you're going to tuck this wire down here so it's nice and neat. Now guys, when I went to take this apart, I'm here to tell you that Kenwood just had these connections just tacked together. And I mean, they were just, I just touched them with the soldering iron, and they come right apart. It's kind of like they knew that some guy eventually in the future was going to be doing something like this. So, what I say is if you're going to do it, make sure to do this correctly and don't just half-ass this. So you're going to take and you're going to run your wire through the actual solder tab, and then we're going to hook it over with a mechanical hook. Okay, so you're going to run it through the right through the eyelet, up major left, through the eyelet, and then hook it over. Okay. Now, the other capacitors that you're going to have sitting in here, you're going to have 101J and a 101J. You're going to need these in a minute. And then you're going to have a 151J. You're going to take this 151J, you're going to put a hook in it, just like this. And you're going to bring it down. Let's lift this wire up a little bit. We're going to bring it down and hook it up to this back pot. Sure, practice it off camera, but then you come to do it on camera, capacitor, and you're going to fight me. Okay, so we're going to hook it around, and then we're going to loop this back around that solid wire so that we have a nice mechanical connection. And then we're going to go and solder it in place. Solder, not solder, it's slang actually, believe it or not. Solder this joint together thoroughly. So now the 21 megahertz is still going to stay functional with the use of this capacitor to ground and the conductor that we just hooked up to it. So now 21 megahertz is going to be in resonance on the input tune. So now let's go do the 10 meter modification. So give me a second. I got to unsolder this from this ground, and then I'm going to reattach it. Okay, so we got our 101 in hand. We're going to take it down here, we're going to hook it through this opening in the eyelet. Hook it through the opening in the eyelet, and then we're going to bring it directly up to the ground pin. And the reason I wanted to unsolder that is I could feel that leg from me twisting these things around and poking my fingers in here, getting a little loose. I want to make sure that everything in here is put together solidly for the customer so he doesn't have to worry about anything. Now, I'm not going to charge him anything to do this. This little bit here I'm not, but the repair work I got to do on this after this is where there's going to be some charges involved. So let's go ahead and hook this up. Now this goes to the closest one to the ground pin. This 101 capacitor. 101J is the part number you're looking for. And it's all been provided for you. Remember, this is the front of the amplifier facing towards me. So this would be the left-hand corner of the amplifier. This is going to be in the right-hand corner of the box. Alright? So now we're going to have to get some wire. And it doesn't have to be that substantial. My preferred wire of death is going to be Teflon because it has such a high breakdown voltage. So let's grab a piece of Teflon here. We'll go ahead and we'll strip this back a little bit. We're going to pre-flux it, pre-solder it. Now, down in here, the third slot from the top, going towards the right, is an open tab on this band selector. You're going to run a wire from here to here. Then on this band selector, you'll see there's another open slot, and you're going to run a wire from there to there. So let's go ahead and do that. Okay, so let's cut back into this, and I want to show you I got the first wire hooked up. It's no big deal. So let's go ahead and move on and do the second wire. And that's it. So now the RF path has a way to get through the induction tune coil. Now you want to keep these wire leads as short as possible. Otherwise you'll get your induction length all messed up. But that's it. The mechanical stop had been removed before it came here. And the reason it came here is his buddy tried to modify this thing to run on 10 meters and they couldn't figure it out. And before the amplifier got damaged or the band switch got broken, he wanted to send it to somebody to be able to look at it and figure it out. Well, fixed. Let's get on with the rest of it now. Okay, so let's take a hot minute and let's go over here and we'll look at the output side and then the input side also. Now there's a couple obvious things that you can see right away that are a problem here, like this little piece of ferrite, which I don't think is absolutely necessary, but I do have another one of. Because remember, the filament, this is part of the filament choke circuit. Your filament voltage is going to come in. There's a choke that's on the opposite side of this board. Your filament voltage is going to come in. It's got to go through these two wires and pass into the tubes. Okay. The other thing that we need to do is we need to go in and remove these capacitors, these chokes, and we're going to ground the grids. I've been to probably 24 web pages in the last 3 days just looking at this amplifier specifically, because this is all I've been eating and breathing and pooping for the last couple days. Has been kenwood922a's. Okay. I'm here to tell you I've never seen any of them have this disc capacitor in place. It's a 47 puff 3 kVA directly from Alibaba component that somebody has put in after the fact. They've also put this jumper bar in here, which is good. Now, they have another modification down here in the bottom, which you guys can't see, but I'll show you. I'll take the camera off tripod and I'll show you here before I remove it, where they're jumping the front and the back boards together. I don't know what that's for or why it's there. So I'm going to look at that really closely. I'm just doing the visual inspection. So back over here to the filament transformer, I really strongly don't believe that this little piece of ferrite does anything other than really kind of keep the wires separated. Very little harmonic resonance is going to take place with one pass through, but like I said, I happen to have another one of these beads that's fairly close, so we're going to make sure to install that because I want to put this back to close to factory spec as possible, because like I said, this guy's going to be using it primarily on the amateur bands. Now if it was a CBer, I probably wouldn't get too excited about that, but this is going to be out there on the airwaves with the guys on 10 meters and 80 meters and so on and so on. So I want to set him up for the most path for success. Let's put it like that. The other thing that I have to do is I know for a fact on the top side I've got to go through and I've got to replace all the light bulbs. So I'm going to just do the 10 meter modification, and then I'm going to do the grounding of the grids tonight. And then this thing's got to go and get set aside, I think, until next Tuesday, I think. I don't have any 10 volt grain of wheat soft light bulbs that are warm. I've got some that are super bright, make your eyes squint when you look at them, LED versions, and that's not what this thing was designed for. So let's go ahead and let's get on with it. Our visual inspection is not giving us a whole lot that we need to be concerned with. This does lead me to some concern. I can tell that this has obviously been modified at one point or another. These guys had just soldered these tabs for whatever reason, but whatever. All right, let's pop these chokes off and ground the grids. Yeah, let's get rid of these. So my particular wire of choice is 1.3 millimeter, or otherwise the gauge of 16 solid soft drawn copper. And I usually start out with putting a little hook on it. So you don't need anything substantial to ground the grids for the most part. So what we're going to do is we'll start off on this grounding lug over here. Let me pre-tin this wire here real quick. You got to go slow because copper is such a wonderful conductor of heat, thank God. Praise Jesus for that electrical property. We're going to go right to this ground post on the corner. Okay? And y'all have seen me do this over and over and over and over and over again with an SB220. It's the same principle. We're going to hook it down and underneath the leg. Then we're going to bring it back over in this general direction. So we want to go down and underneath the leg. Once again, maximizing our surface area and bringing it back in this direction. Now before we go any further, we want to go ahead and add some magic pixie glue to this stuff, otherwise commonly known as solder. We're going to solder that wire down. We're not going to touch it for a minute. We're going to let the solder go back to a solid state. It's really important, by the way. A lot of guys that get themselves in a hurry can't be. Just can't be. So now that that's had a chance to get solid, we're going to bend this down again. We take our pair of pliers and we're going to create ourselves a solid arch. So, go ahead and pre-tin this wire. Get our needle nose again. Grab all our wire, bring it into position, and let the solder flow from tab to tab. Let it solidify again, and we're done. So, this particular tab, we're going to bring it out to the edge, straighten our 16 gauge out, just like that. We're going to cut it. So now, go ahead and tin this wire. Okay. We're going to create ourselves a little hook, just like this. Grab a hold of it, and we're going to bring it right down to this ground lug. Open our hook up a little bit. Oh. tin it, soldered on. This tube has now got a grounded grid on it. It's clean, it's neat, it's not overly ornate or complicated. Let's grab ourselves another piece of 16 gauge wire. Let's do it to the other side. I can remember when I bought this little piece of ferrite, well, bought a bunch of them. That'd be kind of cool, I might have a use for those. Fast forward 5 years later. I didn't think ever, in my wildest dreams, that I'd be stuffing one of these pieces of ferrite, because it was needed, in the bottom side of one of these boxes. Now, this is a continuous drawn piece of wire through here, so they take the legs and they shove it through the board. And so you've got to unsolder it at the pins. Now this is the most important solder connection in this whole dang box, so let's go ahead and make sure we got a mechanical connection. Because when I unsoldered these things have been hot. So let's go ahead and manipulate these a little bit. Here's one. There's two. It's like I always wanted to go to like Dayton. The only ham fest you'll probably get me to go to is like a major one, like one in New York or something like that. Something that's big. I mean, like really big. Somewhere I gotta walk around with a cart. And, man, I don't know. Not a big ham convention guy. Not a big thing like that. I just, yeah. Okay. Just wonder what the little goodies that I would find would be. So the only thing that gives me pause is this capacitor. I have not seen this in the last couple days or the last few of these I've worked on, so I am going to go break myself out a manual and a schematic and let's see if this thing even needs to be in here. I highly doubt it does. This is an aftermarket pan switch. It's close. It's really close. So the shorting bar that's down in here, these two positions are extra slots in the band selector. I'm pretty sure the guy that was working on this wanted to make sure that it didn't fall out of contact. And then instead of running down in the bottom, there's a shorting bar that runs over to this other connection. And instead of summing them back at this connection, you just ran a solid piece of copper over, and I'm fine with that. That's electrically correct. This is electrically correct. Okay, I'm satisfied. Pretty sure this is going to work everywhere we want it to work. And where I was going with that original train of thought is I've been on a lot of different web pages for the 3500Z, and especially particularly this box. This is one of the major things that a lot of the web pages suggest that you do is grounded grids. Now, as you guys all know, those of you all that watch a lot of my videos know that I am a big fan of grounding everything. I love grounding the grids. I don't like having these stupid older than me wire wound chokes in there. They really only come into play when you get way lower in frequency, and it's to help keep the tube stable as the tube is out of resonance and you're bringing it into resonance as you're gripping or tuning the tune and the load. So there's some catastrophic problems that take place when the grounds lose their potential to come back to, or the grids lose their ability to have ground. So I don't I'm not interested in having them in here whatsoever. Just take them out. That's my opinion. All right, let's flip it over. Let's look at the top. So the customer told me in their note that I need to replace most of these granite wheel light bulbs. All that work's going to get done up here, and it's going to get done in a later fragment of the video here. Capacitor bank looks good. Now the bleeders look like we're here. We're talking here now, you guys. These are your bleeder resistors. None of them look broken, cracked, or anything that's going to make me want to go, oh, here's a problem. We don't. So let's go ahead and let's hop over here to the RF deck, the upper side of the RF deck. Here's your load and your tune knob. Now you know that how this works is this circuit, when you move this capacitor, you are tuning to the tube. Okay, so you're bringing this circuit and you're making the capacitance couple to the tube. And on this side, the actual load side, ooh, that doesn't feel right. We are dragging. Woo! I bet you it's this back fin. It's always this back fin. Look at that. Okay. You're tuning to the antenna. Okay? A tank circuit, you're tuning it for its length and resonancy. That took me a long time to understand that. Nobody ever explained that to me in straight, easy English to understand. This allows you to tune to the tube, this allows you to tune to the antenna, and the inductor is tuning to the frequency. Magic, I know. So now, the reason I immediately thought it was this back fin is because of this joint here. Somebody, when they went in to do the band switch, got a little bit of herky with the jerky, and there's a crack here underneath this solder. I can tell you that right now. And so their solution to this problem is to simply put a glob of solder on that thing. And so they've been in here banging around. Well, there's no guard on the back side of this capacitor. If we would have tried to run this with this thing the way it was, we would have had catastrophic problems. There would have been arcing and sparking and shit going on. Jesus would have been called down. There might have been some quiet prayers that took place. I know this guy's tried to run this thing since they did, quote, attempted the 10-meter modification for it. Now, I think this is cute. They didn't send me any anode caps. It's okay. My sloppy hose that I've got that have gone from Drake's to Henry's to Kenwood's to freaking, I can't even tell you how many SB220s I worked on. They won't be offended by this. They have their own anode titties on them. They'll be fine. By the way, I want to throw a plug in there. There's a guy that runs a web page. He's a personal friend of mine. We broke bread. We've hung out together. His name is Chris, and he owns a web page called RF Junk. And Chris does beautiful machine work. And I wanted to show you guys these. Look at this. Hallelujah. This is an anode capacitor, or a heat dissipation capacitor for the anode on a 3500Z. The only place the anode truly makes couplings to the air is at the actual top seal of the anode on the glass envelope on a 3500Z. This works beautifully inside of a Kenwood, or not a Kenwood, pardon me, a Henry, and works wonderfully on the inside of an SB220, and works wonderfully on the inside of a Drake. For this particular amplifier, there's not enough clearance to be able to get the anode to fit between this and the grid cage, the actual RF and high voltage enclosure cage. So what he has done is he's developed one that's half this height, and it has a hookup point here on the bottom. So when you go to attach your parasitics, which is this circuit here, you would take this parasitic off. You're going to attach it to your anode cap, attach the anode cap to the tube, and then you're going to attach the parasitic here to the top of the plate choke. So then it works perfectly. The more surface area that you can give the anode tit for cooling, the better performance and the longer life you're going to get out of your tube. Now, I need a 3500Z. This amplifier here arguably has some of the worst cooling that I've ever seen in an amplifier with a 3500Z. This tube was designed to be cooled from the base up. So normally what you'd do is you'd slide this inside of a socket. Now let's see, do I have any of those really trick-ass sockets? I do. Hold on, let me grab one of these. This is a cool socket right here. Look at this son of a bitch. Isn't that neat? So you go ahead and you insert your 3500Z into the socket, and then you hook your blower up to this end of it. On the top side, what you got here is the absolute best socket I've ever seen for actually cooling. And you're going to have a chimney, a glass envelope that sits over the top of this thing. So you're going to direct pressure cool your feet, the pins, okay? Now the main problem is that the tube itself is a poor design, hence when it was designed. I mean, when they decided they were going to go and put the anode so it could actually touch the atmosphere, then we could go and make bigger tubes in like the 4-1000s and so on. These tits on these tubes get hot, these little feet. They get really, really hot, and so then you got to worry about the metal seal that takes place between the glass and the pins that come out of the bottom. These pins are held on with a silver bearing solder. So you can't go and just put regular, lead tin solder to this. It'll just flow right out of the bottom. Eventually it will, especially with long transmissions. So you've got to use a higher temp solder. So they use a silver-based, silver-bearing solder on these. This amplifier has a single fan on the back, in the back of this thing. It pulls air through the cabinet from many different directions, as I've shown in multiple different videos over the last couple days, and exhausts out. The base of this tube is completely left naked. There's hardly any airflow that takes place here versus this. This would be something that I'd want to put like inside of a Henry and then direct the actual air pressure that takes place off the blower. But you could put a couple 100 CFM blower attached right to the bottom of this thing, and the air is going to rush up over the pins. It's going to flow around the outside of the envelope of the tube, and then with the chimney it'll recollimate the air back together, and it's going to push it right over the top of the anode seal. Well, this is your standard SP220 anode cap. Now my friend Chris, my personal friend Chris, which do you think is going to get rid of more heat? This thing or this little thing? Now they make ones that are bigger and they look like little mushroom hats, but they ain't got that surface area that this has got. So now imagine a glass chimney that comes up, it comes into a little circle piece about the size of a 50-cent piece, and this thing's sitting right in the middle and all the air's got to go through it. How much longer do you think that this is going to increase the life of the tube? Just saying. I just thought I'd throw that out there. Go check it out, rfjunk.com. And if you need to, give my friend Chris a call. Tell him I sent you. He'll take good care of you. He's also the same guy that makes the shockwave antenna. Just so you know. And he makes all kinds of really cool anode caps. I don't see anything up here that's going to give me any reservations on running this the way it sits. Sucker has been hot. These old Taylor tubes, I swear to God, these are, I bought these brand new. My friend Bakerman actually bought these, and I got them from him in a trade. But these are RF parts. The Taylor brand is actually China, by the way, you guys. These 3500Zs have been the benchmark of multiple hundreds of videos. This Z-tube and its other little buddy that I've got. They're both Taylors, they both come from RF parts, and they work phenomenally. I've had a wonderful giant mountain of success. Now, I don't necessarily know if they use silver bearing solder on their pins or not. Because I have had a couple of these come unsoldered over the years. Just saying. But as far as their output performance goes, they spot titties on the money. Now, I'm going to show you something else. Wow, got solder on that one. Solder. Tell me the difference. One's an RF Parts Company tube 3500ZG, and one's a San Marcos, California Taylor 3500ZG. Now here's the screwed up thing, is if we get down in there and we look at the stamp numbers that are in the base, they're about 300 numbers off from each other. They were purchased at the same time. These two tubes have been in everything that uses these. And they've been on every video. These are the ones that I continuously bang up to 3,000 watts for the test purposes on this bench. These two tubes. So you take from that what you want. Just putting that on the table. So let's go ahead and put my sloppy old girls up in there. And I bet you boop. Phone's over there ringing on silent. Guys, it's 9:30 at night, and I know I've got a couple amplifiers for sale at the moment, but I ain't taking no calls. So we'll go ahead and we'll get these suckers mounted up. And if you're going to do this with a new set of tubes, obviously the very first thing that you're going to do is you're going to put the tube in, and without any high voltage being present on the tube, you're going to turn the tube on and watch it for a couple minutes to make sure that there are no leaks inside the tube. That's what we call an air bottle test. I've been over this and over this. So real quickly, I flipped this thing around here real fast. I want to make sure it's wired for 110, which it is. So let's go ahead and let's put this thing on the Variac and see how it works out. Okay, so what we're going to do here is we're going to run this up with the Variac. So it's wired 120 or 110, and I've got all the safety interlocks bypassed with some really high-tech tools. I'll show you here in a second. Brilliant. Brilliant, if I don't mind saying so myself. So what we're going to look for is this meter here. We have it set in the high voltage setting. So first we're going to watch and see if this comes on. Now remember, these have got a contactor in them that latch up as part of the starting circuit, and you're going to hear it. It's going to go bzzz, boom, and it'll latch up. So we're not going to drag through the motion too awful bad. If there's any kind of problem, it's going to show up as resistance and me turning the knob on the Variac. So here we go. We're at 0 volts. There's 20. I don't think I got good contact on the Variac. Let's go to the bottom plug. There we go. So our volts are starting to come up. There's 25, 30. Now listen for it. Hear it buzzing? That's really hard on that contactor, so we don't want to do that too often. Okay, so we're at 110 volts on the input right now, and all but one of the lights is working. So that one's working full chooch. So we got good plate volts at 3,000 volts. All right, let's go see if our 10 meter modification is working. Let's go ahead and we'll shut it off with the Variac. Well, let's get the Variac out of here, and we'll go back to running it straight off the wall outlet. So I want you to check out, make sure I got peak kit on. Yep, okay, we're on 1X. I want you to check out my beautiful safety interlocks of paper. Paper is non-conductive for the most part until you get to really high voltages. So Now, we're going to go over here. We're going to go to like 23.3.250. Okay. So right in the middle, we're at 28 megahertz right now. 28.325. So we're in the, technically the 10 meter band. Now really all of this doesn't count for a whole awful lot because, well, I'm not on an antenna. I am into a dummy load, as always. It's a 1,000 watt slug in peak, 1,000 in average, 5 watt slug in reverse back from the Bird 10,000 watt dummy load. So let's set our radio up. Let's take this 5 watt element, we'll flip it around. Nope, too much. So we'll set it up so we're going to put 4 watts of carrier into it. Now, with 4 watts of carrier, you should get around pretty close to 100 out of it. So let's go ahead and we'll bring the amp on now. You got my tubes in it, my IMAX in it. Now I got a whole story to tell you about that here in a second. So let's go. Whoa, okay, we're good to go. Yeah, we just made over 200 watts. So let me turn this 5 watt slug around so we'll quit killing it. And I'm going to zoom this in so you guys can see what I'm doing here. We're going to tune this thing in and peak it out to run. Trust me, I'm going to validate everything. I'll show you all the meters and everything here in a second. We're looking at that end scale. So we're going to put like a 25 or 30 watt carrier into it. Okay, there's a 400 watt carrier. Now what I'm doing is I'm balancing between the tune and the load, or otherwise the plate and the load. Because remember, this tuner, we're tuning to the tubes. This tuner, we're tuning to the load on the output side, and the tank coils for resonancy. Now, I'm looking at my grid dip meter and also looking at my carrier level and letting my eyes walk back and forth. And I'm dipping the grid current. Now as you're seeing, the output power is going up, but I'm tuning it with a combination of both meters, the maximum output power with the least amount of draw here on this meter. Okay, that's your amps, your grid amps. So now let's go ahead and we'll back the carrier down a little bit. Hello. So we're going to make it so it only puts about 100 watts worth of drive into it. So with a 100 watt radio going in, otherwise like most ham radios today, so we're getting over 1,000 right now in peak power. Sorry, phone rang. Okay, so we took this up to the 2x position. So now we're getting like 1,200–1,400 watts out of it. Now we're going to go ahead and play with our plate and our load again, or those tune and load. Now there's 1,600 watts right there. With just us redipping the tune and the load, or otherwise the plate and the load. If we look back down at this meter down here on the face, which I don't know how well you guys can see it, but with 1,600 watts, 1,700 watts going out, now that we have it tuned properly, and we're not just looking at the watt meter, we're actually looking at what it's pulling for plate draw, or amperage draw on our plate meter, on our plate. See how it's swinging forward? But we're only pulling 400 mils worth of current. well within spec of the tubes, well within spec of the power supply. I changed the load, and if you notice, our peak power is going up just a hair, but the amp load's going way up on the plate. It came up 10 mils. Zero signal with about 200 watts worth of carrier on AM is 300 mils. Forward swinging to about 4.5 mils. It's about 450 mils. That's beautiful. That's what we want. So now let's validate what we were talking about here. Here's the frequency that we're on. 10 meters. No, it's not going to come out. We're on 10 meters. See that? And now, let's go look at the reflect meter. So first we're going to shut off the 2-pill. That's a 5-watt slug and reverse. There's no input reflect. No pass-through reflect either. Kenwood already did all the work for us. So like I was saying in the previous segments, Kenwood already did all the work for us on the slug, so you don't need to get in there with a screwdriver and adjust anything. All you got to do is hook the slug up, which is really simple. Now the output side's already got it present. Now the customer said to me, well, I can't get it to work on any of the bands. And then he admits to me that they were trying to use it on just a radio that only does 10 meters. And I was like, oh, well, okay. So the band selector, the back one was put in properly. The front input selector was not wired up correctly, and it needed a couple modifications, which I showed you on video. So now, the other thing that I want to tell you is the story. So I called the customer and said, hey man, great news, I figured out what's going on with your amp, blah, 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 blah. And he goes, great. Well, I told him, I said, I got my tubes in it, and I'm going to run it tonight. And he goes, well, have you had a chance to test my tubes? And I said, what? Your tubes? And what he meant by that is, and then he says to me, well, I put them in a small box and I had it in the exact same packaging in the amplifier. Now look, customers don't send me their 3500Zs. I have lots of them. I have multiples that are new in box. I have multiple new iMacs. I have lots of these. So I tell all the customers, don't send me your tubes. I don't need them. Don't ever want to see them. You keep them on your end. I'm going to use my sloppy old whores that have been in everything. And I mean, these tubes that are in here have been in every kind of 3500Z box they ever made, and I can guarantee it. And they're straight from RF Parts Chinesiums. They work great. He says, no, I sent you up my tubes to test. And I went, I don't know where your tubes are. Now, I've been doing this for a hot minute, and I have yet to accidentally send the wrong amplifier to the wrong guy or lose anything. But now what we did do is my wife did take over the organization of the input of stuff, and she did come out here and reorganize everything, which has led to a couple weeks of me trying to figure out where everything is at. But tonight that led to a 2-hour search process to find this box. So now in this box, after 2 hours of searching, it's like I told the customer, I don't know where your tubes are, bud, but I'll find them. But I had some other personal things I wanted to go do. I went to a violin concert for my kid tonight. And I'm sorry. My kid, my wife, my family trumps this shit any day of the week. They come to me and they say to me, they want, hey dad, let's go do something. I'm like, peace. I'm out on the radio thing. So I went to digging. Now I've got 1, 2, 3. I got 6 giant shelving units in here that are completely full of stuff. And one whole side is just for the incoming amplifiers for repair, and the other one is all the parts. That's just in this one area. And then I got a bunch more stuff, and another 5 units over there, shelving units, are full of parts. So you would assume that these would be with the input where stuff is, when stuff gets checked in, right? Well, after digging through all 700 something amplifiers I have here for repair at the moment, I thought, well, let's go over and let's take a quick look. Oh, cool, these are iMacs. And there's the original Z anodes with the screws. Because remember in the first segment I was bitching about how I didn't send me his anodes? Oh, and the other thing I want to cry about is this is not the appropriate way to package these ever. There's broken pieces of styrofoam and stuff in here. Please, don't send your tubes to me like this. Either send them in individual flat rate boxes or a Patron bottle. I did have one show up here in a dirty sock and some empty water bottles one time is what the guy decided to pack his 3CX1500A7 in. Which I was just gobsmacked his $1,500 tube. Okay, I'll give you credit. This is actually not that bad of a packing job. Look at the anode. It's a miracle that these tubes made it here. That's a miracle. I'm going to have to do the vacuum test on these. You know, we're going to check them without the high voltage, make sure they're not an air bottle. He put them in the same enclosure that this amp was in, which is, whoa, bad. Like, whoa, Nelly, hold on to your underwear bad. Like, scary bad. Because all it would have taken was for the shipper to take and drop the thing on the edge of it, and I'm sure this box was packed on the edge of it, and your about $500 a piece iMaxes would have just been shattered. So, what I suggest people do is this is Matchlight's idea of good packing. This thing here. This thing here. And in here is some styrofoam. But now, that's not my idea of good packing. So usually when we ship amps or tubes out of here, we'll send one tube per flat rate box. Let's see, I know over here I've got, sitting right here on the shelf, because I had to go through every single flipping thing tonight. I like how RF Parts packs their tubes. This will save me from digging out an iMac tube. This actually belongs to a friend of mine. I'm just going to use it. Okay, this is how tubes are supposed to be packed. There's approximately 1.5 to 2 inches of foam padding in every direction around the tube. Do a visual comparison. See that? So, we tape the foam insert out. Look at that. Very well protected. It's a brand new 3500Z from RF Parts. Back when Penta was making them, I do believe. Don't quote me on that. The next step, mister, is we're going to check your tubes. These two here. That I'm so grateful I found. What my wonderful wife did is, since no one really sends me their 3500Zs with their amplifiers, because I tell them, please don't. I don't want them. I don't want to take on that liability. Assumed that they were tubes that I had purchased, because that happens quite often around here, by the way. And well, filed them over on the parts shelf, and she wanted to make sure they didn't get dropped or damaged, so she had them on the back of the shelf, hidden behind a whole bunch of other stuff. Took me a little while, but it was worth it. I found your parts. They're here. So my record stays clean. Haven't lost one yet. Don't plan on doing it anytime in the near future. So what we're going to do next is we'll check these tubes, but I'm not going to bother with this until probably next week. Today is the 13th of December, and I am not going to ship this thing till next month. Tomorrow is the 14th, and I'm officially, well, actually today, because it's like 3 o'clock in the morning, no longer accepting anything in for repair until the end, or the middle to the end of next month. And that has to do from the holiday rush that is currently going on. And the little brown shitbox kicker's beating the crap out of everything. So, I want to replace all your lights. Your on-air and your receive lights are not working. These need to be replaced. And then the 4 lights across the top, I'm going to replace those all out with soft white light bulbs. Not bright, burn your eyeballs out LEDs that make it look silly with the actual right part. So I'm going to let these tubes cool off. I'm going to pull them out. Stick your tubes in. I'm going to put the whole amp back together. I'm going to sit it on the shelf and I'm going to come back to it next week. Gentlemen, on that note, and through the magic of cinematography magic, we'll see you in about 3, 2. Okay, so guess what? Believe it or not, like 2 weeks have gone by from the last segment. I had to go back and reload everything into the computer, bring myself up to speed with where I was at on this amp. The only thing I did is I had a post-it that hung on the front of the amp that said, change light bulbs. I was like, okay. So I went in here, and now that I got my replacement light bulbs in that came in here about a week and a half ago, and we got New Year's and Christmas and all that other crap out of the way, I went in here and I pulled all the light bulbs out for all the meters on the front, and they're all brand new. All brand new 8-volt grain of wheat light bulbs. Okay? So, all that being said, now that I was able to find your tubes, we put your tubes inside the deck, and we're going to give this thing a hot run for its money. Your tubes. With the actual stock anodes that are supposed to be, the anode caps that are on it. So, let's grab the lid. And, got to make sure our highfalutin safety interlock is bypassed here. Okay, paper's good and shoved in the hole. Alright, so, on that note, Quantec. Look at that, come right on. So now we got fully functional 4 lights there. And look at what happens when we step on the foot pedal. Oh, everything works. Low and high. This thing looks so crispy with all the lights on. Check it out. Soft white, not blue, not white LED, make you go blind, but nice and soft white light. You know what? I don't like how that's sitting. Hold on a second. Let's let that high voltage bleed off. Not really. No, not really, Dad. I want to go and stick my fingers in there with the high voltage up. Come on. Come on. Come on. Down to 0. Party people. Boom, boom. All right. Let me go in here. I want to adjust this one light bulb. It's sitting a little low. Safety third. There we go. There we go. I was adjusting, it was that the light bulbs are even. Because I noticed when I shut the lights off, it was not casting an even shadow. If you're going to do something, do it right. Do be thorough about it. You know what I'm saying? Let's look at that. Now they're equally lit, the same amount of light coming straight down. Ooh, 3500Cs. Okay, let's quit totally dinking around here and let's get on with this. Because I want to get this sucker wrapped up. It's time for it to be done. The customer has been more than patient, in my opinion. So right now we're on the 2x scale. Okay. Turn on a little bit of drive. 210 watts worth of drive. That tubes are at full output, by the way. Let's go to 5x. Now let's play with that for a second. What am I missing here? here tripping trying to figure out why I won't do over 2,000 watts. Let's go to the high mode. So we're in the 2x position. Now we'll go down to the 5x position. So, reading that middle scale, adding a couple zeros to it. Needless to say, brother, your tubes are golden. All your meters are working. Even your RF meter is relatively close. Check it out. It's a peak reading meter. So we're looking at that far right hand scale there. That's it. That's all she wrote. Everything is working the way it should. Completely restored back to fully functional. Band switch repaired. Grounded the grids. Made it so it'd run in the 10 meter position over here. Legally, in the proper way. Input tune is good. So on that note, gentlemen, I'm out of here. I got to go do some other stuff, and I'm glad I can finally get this puppy done. I'm going to take it apart, pull the tubes out, get ready to shit this amplifier out of here and get it on down the road. My name is BBI, and without a shadow of a doubt, I'm in the biggest mud duck in Idaho. Come check us out, www.bbiamps.com. Come find me on Facebook, Twitter, Snapchat, Instagram, right here on the YouTube Garler. If you like what you see, make sure to click subscribe. It makes both of us, you and me, feel better about things. So many more to do. So many more to do. I appreciate you guys, and thank you for your support in all the projects. Bump from the biggest duck in Idaho. I'll see ya. Bye.